A bullet loses 1 by nth of its velocity passing through one blank. The number of such okay, uh, apologies, this is one blank, and this also is not plans, it is planks, okay, that are required to stop the bullet can be. See, this is a really good question. I would say is one of the most beautiful questions in this series. This question can be solved in solved by two different concepts. One is using the kinematic equations of motion, v square minus u square is equal to 2as, as we were doing for the past couple of problems. The next method would actually be utilizing the work energy theorem, which for those people who are beginners wouldn't be a familiar one. I do understand that you've learned the work energy theorem in your lower classes, but since that we have not discussed concepts of work energy theorem, I don't want to go to that way. So let us now try to focus our solution based on equations of motion, due to which I have to admit that the solution may be more lengthy. As in, work energy theorem can solve this question in 3 steps, but equations of motion may take more than 5 or maybe 6 steps, so it may take twice the time. But the point is to understand the concept. And suppose a question comes out of surprise for a test paper, and you don't know which chapter is the question is being asked from, which is what happens during an entrance exam. So let us try to be in that particular situation and then try to solve a question randomly out of the concepts what we know. So it goes like this. There is a wooden blank. I'm sorry, there's a wooden plank. There's a bullet. It enters the plank. It comes out of it, right? So it enters the plank and it comes out of it. And then it enters the next plank, the next plank, so on, and it eventually reaches the last plank wherein the velocity becomes 0. Let the thickness of one plank be x. Let the thickness of one plank be x. Let the thickness of one plank be x. Let the thickness of final plank also be x. So what is the thickness of one plank? X. Let there be total capital N numbers of planks. Okay. So this is plank 1, this is plank 2, this is plank 3, this is plank N. U is the velocity by which it is entering plank 1. V is the velocity by which it is leaving plank 1. So considering plank 1, let me redraw the diagram again. So distance moved is x, velocity which is entering it u, velocity which is leaving is v. So what I'll do is I'll mark the velocities as u, v1 coming out of 2 as v2, coming out of 3 as v3, coming out of last as vn, which basically is 0. So considering plank 1, equations of motion would be v square minus u square is equal to 2as. What is v? V is v1. So we have v1 square minus what is u? U is u square into 2 into a. S would be s1. What is s1? S1 is basically x here. Or let us write it down. S1 here is thickness of one plank, because we're dealing only with the first plank. So if we write this, we can say that v1 square minus u square is equal to 2 into a into x. Now comes the application of the first part of the question, which says 1/n of its velocity is lost, which means if this is u, then the first v1 should actually be u minus 1 by n of u, just 1 by n into u. Therefore, we can say that v1 is u minus u by n, or v1 is un minus u the whole upon n. Okay. Let us now substitute this v1 here. So we can write this as v1 can be replaced by un minus u by n the whole square minus u square is equal to 2a into x. So let us make a small algebraic manipulation here. So this will become un minus u the whole square minus u square into, I'll take the LCM as n, so this becomes u square into n square, because this n is under the bracket, so that also will become n square. So this is equal to 2 into a into x. Okay. So what would be the value of a? The value of a would be un minus u the whole square minus u square n square the whole upon n square times 1 by 2x. Okay. Now what we'll do is we'll consider the complete motion. Which means we'll see the motion of the bullet starting from the first plank, right? First plank, it emerges out, it reaches the second plank, and so on, and it eventually reaches the last plank with velocity vn. And in this case, vn is equal to 0, because we are being said that the bullet is being stopped. So in the last case, the velocity is equal to 0. Now, see, for this complete motion, what can be the equation of motion? It can be written as v square minus u square is equal to 2 into a into s. Now, a is the common retardation faced by the bullet, the value of which we have found out. Now, what remains here is s. See, what is s? Distance covered in the complete travel. How much is the distance? Let us see. What is the distance of one? What is the thickness of one plank? It is x. In which case, what would be the thickness of 2 planks? It would be 2x. What would be the thickness of 3 planks? It would be 3x. 4 planks, 4x, 5 planks, 5x, n planks, it would be nx. So here the distance is basically nx. Let us now substitute these values here. So v square is 0 minus u square is equal to 2 into a into, what is the value of a? A, I'll write it down from here, which is un minus u the whole square minus u square n square the whole upon n square into 1 by 2x into n into x. So this is the given expression, this is the expression for the complete motion. Okay. Now, while considering this, what we can say is u square is common in all the terms in the numerator. Okay, let me just expand that also. So we have u square is equal to, see, 2 and 2 here will cancel off, right? Okay, let me just check it. So we have 2, I've written 2 here. A, the value is u minus 1 by 2x. Okay, that is also written. Okay, and then we have s, which is n into x. Okay, so now we have 2 into, if we take u common here, since u is inside the bracket with power 2, while taking u as common, you should take the power also common. So we have u square into n minus 1 the whole square minus u square into n square the whole upon n square into, so this becomes x and x will cancel, so we have into n here, right? Okay, yes. So now if we take u square common from both terms, this becomes u square is equal to 2 into, okay, so we cancelled off 2, right? So this 2 won't be here, 2 is not here, so all we have is u square into n minus 1 u square into n minus 1 square minus n square, the whole upon n square into n. So now u square and u square will cancel off. Oh, okay, I missed one more symbol. This is minus here, so minus here. Okay, so now what we'll do is, since u square is cancelled off, we'll take n square to the RHS. That becomes minus n square is equal to n minus 1 the whole square minus n square into n, which means n is equal to minus n square the whole upon n minus 1 the whole square minus n square, which is equal to minus n square by n square minus 2n plus 1 minus n square, a square plus b square minus 2ab. This is equal to minus n square by n square and n square will cancel off. So what we get is minus n square by 1 minus 2n, or we can write this in a different way, n square by 2n minus 1. So capital N, which is the number of planks, is equal to n square by 2n minus 1. Let us now check the options. So the options is option A, n square by 2n minus 1.